Hey guys, this is section 2.5 notes, algebra 2. Um, so for this, we're actually going to skip the warm up and we're going to go right into using square roots to solve certain things. So the first thing is using square roots to solve. Okay, so what we're going to do is we're going to first need to factor this first part. All right, so we need to factor. So, all right, we have a of 1, so it's going to be x plus or minus something and times x plus or minus something. Factors of 49 that add up to 14 are 7 times 7, so it becomes 7x plus 7 and x plus 7 as this is factored, right? That's our m and then it's equal to 25. Now, we can rewrite this as x plus 7 squared because it's two things being multiplied by itself, right? They're both the same thing. So we're going to rewrite this as x plus 7 squared, okay? And then we have that's equal to 25. Now we have two things that we can take the square root of, right? So we can take the square root of 25, we know, and we can also take the square root of x plus 7 squared, right? The square root's just going to cancel out that square. So, right, let's take this square root. Square root of this, square root of this. Okay, so square root of 25, remember, we get two solutions. It can be plus or minus 5. Okay, now we're taking the square root of this. Our square is just going to cancel out, and we just get x plus 7 left over. Now we have positive 5 equals x plus 7 and negative 5 equals x plus 7. So we're going to get two solutions. So first we'll set it up with positive, right? Positive 5 equals x plus 7 and solve for x. And then we have, so plus or minus 5. The other one is negative 5 equals x plus 7. Right? And then we're going to solve for x, minus 7 to the other side. We get negative 2 equals x. Minus 7 to the other side, we get negative 12 equals x. So these are our two solutions. Okay. So this is how we solve by taking the square root. So essentially when you get a question and it's set up like this and it says use square roots to solve, right? Most of the time you're going to get something where it's like x plus 7 times x plus 7, where you can rewrite it as x plus 7 squared. Okay, so you're going to look for something like that so that you can take the square root of both sides and then solve. Okay, so these are some tried on your own ones, right? So again, right, we're looking for a perfect square over here. So we want something squared, right? And this one would be, right, we want to factor it. And then it should be x plus or minus something squared, right? So we're looking for a, both of these should be the same, right? Both of these should be the same. That way we can take the square root of these sides. Okay, so try those on your own. Pause it, and then I'll show you guys the solutions for them. All right, so hopefully you tried them. The solutions we get, right? When you factor this, it becomes x plus 6 times x plus 6, which we rewrite as x plus 6 squared. This one we get x minus 8 times x minus 8, because the factors of 64 that add to negative 16 are negative 8 times negative 8. Right, take this square root of both sides, right? On the left side, we get a plus or minus, right? And then the right side, the square and the square root cancel out. And then you just need to solve for x for the positive. this is wrong. This should be positive 9. Okay. Which will change these. So positive 9 minus 6, so x equals 3, right? Because we get 9 equals x plus 6, and we get negative 9 equals x plus 6. So we get positive 3, and then we should get negative 15. Right. Glad I caught that. All right, and then the next one, again, it's positive 3. I don't know why I wrote these wrong, but right, so we get 3 equals x minus 8. We add 8 to that, so we get x equals 11. And then negative 3 equals x minus 8. We add 8 to that, we get x equals 5. All right, so those are our solutions. So don't make the mistake I made on this. All right, so now we're going to use a thing called completing the square. Okay, now one thing to remember is that not all trinomials are perfect squares. All right, so in the last ones about using square roots to solve, we had perfect squares for each trinomial, right? In the example 1, we had x plus 7 squared, right? And then the try it on your own, we had x plus 6 squared and x minus 8 squared, right? They were perfect squares. Not all of them are going to be perfect squares, so we have to use this completing the square way of solving, okay? So to do this, we need to find a perfect square, okay? So to create a perfect square, right, what we're going to do is we add the formula b over 2 squared to our x squared plus bx, okay? So, right, this gives us x squared plus bx plus b over 2 squared, okay? And then that allows us to get a perfect square and rewrite it as x plus b over 2 squared. Okay, I know this is a little confusing because there's no numbers, and it will make more sense when we actually use numbers. Okay, so right, so essentially we're going to need to use b over 2 squared, and then in our perfect square it's just going to be b over 2 because that square cancels out. Okay, so right, we want to rewrite this as, right, this is in x squared plus bx plus c equals 0. What we want to rewrite this as x squared plus bx equals negative c. Okay. Okay. So now we get x squared plus bx at 8x, and then opposite of c, because we moved it over, equals negative 5. Okay. So again, this is your b. So now we need to find b over 2 squared. So 8 over 2 squared is equal to 4 squared, which equals 16. Okay. So I'll write the steps here. Right, so steps. Our first one is isolate x squared plus bx, right? So we move the c over. Okay. The second one is, which we just did, is find b over 2 squared, right? Now our third step is we got b over 2 squared is 16, right? So we need to add 16 to both sides. Right? So we add this 16 to both sides. So x squared plus 8x plus 16 equals, we had -5 on the right side, and then again we need to add 16. Okay. Now, we have a perfect square on this side right here, right? This perfect square is x plus 4 squared, right? That's because what we said over here is x plus b over 2. Well, b over 2 is what's inside this parentheses. So 4 equals b over 2, right? Because 8 over 2. So that's what goes here for the 4 for the perfect square. And what that's equal to is this 5 plus -5 plus 16, which is 11. Okay. And now, right, we have put it in our form x plus p squared equals q. Okay. So this is what we were looking for, right? And then, so this is just completing the square and setting it up. And then further on, we'll go over how to solve them. Okay. So the fourth step was to rewrite as, right, x plus b over 2 squared, right, and b over 2 is 4, is equal to um, our, I guess we can call it q, right? They call it q, right? So that's what we want to do for this. Okay, then we'll go into solving them. But first, I'm going to have you try one on your own. Try completing your square on your own, and then we'll go through it. So I'd like you to try this on your own, right? Again, you want to first to set it up is x minus 6x, and then move the 11 over so equals 11, right? And then you need to do b over 2 squared, right? And again, your b equals -6, right? And then again, your p, right? Your p should be b over 2. Okay. All right. So, right, b over 2 squared gave us 9, so we had to add 9 to both sides. Okay. Then we rewrote this, right? Our b over 2 was -3, and that's where this -3 comes from. And then we set it equal to 11 plus 9, 18. Okay, so again, that's how we do it. You move the c over, do b over 2 squared, you add that to both sides, and then you rewrite it as a perfect square, which is just x plus b over 2. Okay. All right, like I said before, right, we'll go into solving now by completing the square. Right, so your first thing is to complete a square, set it up as x plus b over 2 is equal to q, right? So first, first set up as x plus b over 2 squared equals q, right? So to do that, right, first we do x squared minus 2x equals -3, right? Our b over 2 squared, I'm going to do on the side, -2 over 2 squared equals -1 squared, which equals 1. Right, so I'm going to add that 1 to both sides. So x plus 2 minus 2x plus 1 equals -3 plus 1. And then again, right, here's our b over 2. Here's our -1. So now I need to rewrite this as x plus b over 2 squared equals q. All right, so x, and then we said our b over 2 is minus 1 squared is equal to negative 3 plus 1, which equals negative 2. Okay. Now, right, we're going to solve this like we did in the first example where it said solve by taking the square root. So now we're going to take square root of both sides. So square root of this, square root of this. These cancel out. We get x minus 1 equals, and then now remember back to last section when we have square root of a negative, right? Square root of negative 1 is I. So we're going to pull out an I, and then we cannot take the square root of 2, so it stays as square root of 2. And then whenever we take the square root, we get plus or minus. Okay, so now we need to solve for x, right? And make sure, right, we do plus and minus, right? So we get x minus 1 equals I square root of 2, and x minus 1 equals negative I square root of 2. We have to add 1 to both sides. X equals 1 plus I square root of 2. And then x equals 1 minus I square root of 2. All right, those are our two solutions for them, right? And again, the I comes from the negative number under the square root, right? We know we can't take the square root of a negative number, but we know square root of negative 1 we can represent as I from our complex numbers section. So now what I'd like you to do is pause it and try these two on your own, and then I'll show you guys the solution. So here's the solution to them. Right. If you want, your first thing you want to do is move the positive 8 over, right? So you get x squared plus 4x, and then you leave a blank space for that b over 2 squared, right? And then we have minus 8. So then we have to solve for b over 2 squared. So b over 2 squared, we end up getting 4 here. So we add 4 to both sides. And remember, this, right, x plus p squared equals q, right? P is equal to b over just b over 2, right? Which ends up being just 2, and that's where we get that plus 2 from. Then we need to square root both sides. On the left side, we just get the x plus 2 because the square root and square cancel out. And then the right side, we take square root of 4, which is 2, and square root of negative 1, which is I. And we know it's a plus or minus because there's two solutions. And then we move the 2 over to the other side. The next one, same thing, right? Move the 17 over, so we get negative 17 on the right side. We do our b over 2 squared, and we get 16, so we add 16 to both sides. This is our p, right? Our b over 2 is just our p, so we get x minus 4 here. Take the square root of both, right? And we get x minus 4 equals plus or minus I, because square root of negative 1 is plus or minus I. Move the 4 over, and we get 4 plus or minus I. All right, the last part of this is writing a quadratic equation in vertex form and finding the max or min. So this is going to be very similar to the last problem where we, actually not the last problem, it's going to be similar to example 2, okay? So similar to example 2, right? We're not going to solve, but we're going to use that x plus p squared equals q form, right? As x plus p squared equals q form. And what we want to do is put it in vertex form. So what we're going to do is subtract that q over. So we're going to actually put in 0 equals x plus p squared minus q, right? This is what we want for our answer, right? So our first step would be to, right, get x squared plus bx by itself. All right, so x squared plus 6x equal, actually we'll leave it blank, and we'll set it equal to positive 6 because we need to add 6 to the other side, right? And then now we need to, right, solve for our b over 2 squared and our b over 2. Right, so solve for p, which is equal to b over 2, and our full b over 2 squared, right? And that's what we're going to add to it. Right, so right, b over 2 squared is equal to, b is 6 over 2 squared, which equals 3 squared. Right, our 3 is now our p. Right, and then we get 9, so we're going to add 9 plus 9 to both sides. Right, and now set up as x plus p squared minus equals q. Right, so sorry, we have x plus p, right, which is 3 squared, is equal to q, which is 6 plus 9, which is 15. And then now the only difference between this and example 2 is we want to put it in vertex form. So we're going to subtract q to other side. All right, so and we're just going to set it up as f of x equals, right? So actually I'm going to put f of, okay. So, right, I'll put it in red again. So f of x equals x plus 3 squared minus 15, right? So that is in vertex form, okay? Okay, so that's, again, x plus p squared minus q, and f of x equals that. All right, so that should remind you back to section 2.1, vertex form. And then the last step is just identifying min or max, right? So in this case, our A is technically 1, therefore it opens upward, right? We know if it opens upward, then we have a minimum at y value of vertex. So our vertex, right, is h comma k, right? Well, our h is -3 because we have +3, right? And then our k is -15. So -3, -15. Therefore, our minimum we have is at -15. Right? And that's when x equals -3. And that is our solution. So we needed to first find this and then find this. Okay, so you just essentially do example 2, then subtract that q over and set it equal to f of x. And then you figure out whether you have a min or max depending on your a, right? Your a, if it's negative, right, you know you're going to have a maximum. If a is positive, then you're going to have a minimum at that y value of the vertex. So what I'll have you do is try these two on your own, right? So first, you want to set it up in like we did in example 2, where we completed a square, put in x plus p squared equals q form, subtract the q over, and then find the vertex. And that vertex will tell you where the min or max value is, depending on if a is positive or a is negative. So remember, if a is positive, we have a minimum. If a is negative, we have a maximum, right, at y value, a vertex. Now, here are our solutions. So, again, you move the 11 over. And so in the way I wrote the solutions in this, I just wrote the y in on the other side, but we just wrote f of x in the notes. So either way, you could write this as f of x, right? But what we did was kind of just left this y out, which is fine. Same thing here. I kind of just left the y out and made it f of x. Okay. But same way to solve, right? You move this over. Did this wrong though. This should be a positive 15, which should make this what, 64. Okay, so it should be negative 64 over here. So minus 64. So our vertex would be negative 64. And so we'd have a minimum at negative 64. All right, sorry about that mistake, but those are your solutions.